Let's look at Chapter 3, Lesson 6, Review. We're going to do the algebra part first, where we need to find a rule for each set of cards. Okay? Number 1, we have the front is 7 and it goes to 21. Then we have 8 goes to 24 and 9 goes to 27. So I need to think about how I got 7 to 21. So I could do adding and see how much that would be, but I know that I could easily know that 7 times 3 is 21. 8 times 3 is 24, and 9 times 3 is 27. So what you would do is multiply the front by 3. Let's move on to number 2. The front for the first one is 28, and the back is 7. 36, the back is 9. 16, and the back is 4. So I need to think about how each of one of those got to that. I could do subtraction because the number is getting smaller, but I know that 7 and 28 are kind of have something in common. 9 and 36 do, and so does 4 and 16. Now, since 4 and 16 are the lowest numbers, I'm going to work with those first. I'm going to think, what can go into 16 and get you 4, or what times 4 could get you 16? So I know that 4 times 4 equals 16, or I know that 16 divided by 4 would equal 4. Let's do the same thing for number 9. What can I do to 9 in order to get 36? I can multiply it by 4, or I could divide 36 by 4 to get 9. And the same thing with 7. I could multiply it by 4 to get 28, or I could divide the front by 4 to get 7. So be specific in your rule. I'm going to say that I can either divide the front by 4 or multiply the back by 4. Let's look at number 3. I need to see what the front is and then what the back is. So 18 is going down when it goes to 11, 23 is going down when it goes to 16, and 31 is going down when it goes to 24. Now, looking at these numbers, I don't recognize anything that they should have in common. They're actually looking like a pretty odd pair of numbers. So I'm going to go with adding or subtracting, because that's usually what you would do if the numbers have no relationship whatsoever that you can think of. So I know that 18 minus 7 equals 11. 23 minus 7 equals 16. And 31 minus 7 equals 24. Now I could do the inverse and do 11 plus 7 equals 18, 16 plus 7 equals 23, and 24 plus 7 equals 31. So what I would do when I'm writing my rule is that you would subtract 7 from the front or add 7 to the back. Let's move on to the problem solving. We need to find a strategy in order to solve. Number 4 says a small pool holds 500 gallons of water. It takes 1 minute to put 5 gallons of water into the pool. How long in hours and minutes will it take to fill the pool? So looking at this problem, I noticed that the pool is 500 gallons and it takes 1 minute to put 5 gallons of water into the pool. So thinking about that, I need to figure out how many groups of 1 minute 500 gallons would be. So I'm going to put 500 in the box and 5 outside. By doing this, I can divide 500 into groups of 5 to figure out how many minutes it would take. So 5 goes into 500. In order to do that, 5 goes into 5 one time. 1 times 5 is 5. 5 minus 5 is 0. Bring down the 0. 5 goes into 0 how many times? Just 0 times. 0 times 5 is 0. Subtract, I get 0. Bring down the last 0. 5 goes into 0 0 times. 5 times 0 is 0. Subtract, and I get 0. So, looking at this, I can see that it will take 100 minutes. But I'm not going to write 100 minutes because that's not a logical way to put it on there. Instead, I need to think about, would 1 hour be 100 minutes? So I know 1 hour is 60 minutes. So I can subtract that, and I get 40. So I know I have at least 1 hour, but I can't do another 60 because that's just 40. So 1 hour and 40 minutes is how long it would take to fill the pool. Let's look at number 5. 4 boys and 4 girls volunteer for a committee that will have 1 boy and 1 girl. How many different committees are possible? So looking at this, I know that there's 4 boys and 4 girls, and that the committees just have 1 boy and 1 girl on it. So I need to figure out how many are possible. In order to solve this, I would make an intersecting chart. So I have 4 boys and I have 4 girls. Now, an intersecting chart, you're going to be able to find the possibilities by drawing your lines and then counting how many times they intersect. So those are the girls. And those are the boys. Now remember, intersecting lines are where they are crossing. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I know that there'll be 16 different committees. There's other ways that you can do this. You could make a chart with possible committees on it, but use the way that works best for you.